At this time, without further ado, I would like to welcome the first student presentations. And this team is coming from the university right here in town, Florida International University. Their team name is Sol Urbano, represented by Azaz, Elaine, and Amir. And their mentor is Mr. Eric Sibila. So welcome them on.
Good morning, everybody, and thank you very much for giving us the opportunity to present. Our team name is Sol Urbano, and for today's presentation, Eliane, Izas, and I are planning to talk about our proposed project named as Smart Public Transportation Services using solar power bus stops. At the beginning of the presentations, we would like to talk about executive summary, and then explain the PV technology bus stops, Cuba transportation infrastructures. And in the middle of the presentation, we're going to show the video clips and the methodology, analysis, discussion, planning activity, and finally conclusion will be presented. The main goal of the project is implementing the solar power bus stop in Havana, providing the public an opportunity to learn about feasibility of utilizing the solar energy, proposing planning activities to engage the stakeholders, and demonstrating a synergistic integration of interdisciplinary research team, including the transportation engineer, electrical engineers, and economists. Enhancing visibility at night and providing a greater safety, increasing the level of education regarding the green energy integrations are the main benefits of that project. The approach, this project has the three approach. The first is collecting the transportation and electrical informations, and then estimating the overall cost of the proposed solar power bus stops. And the last, selecting the key bus stops for installing the PV technology. To complete the project, we reviewed the current PV technology implemented in transportation services, collected the information from Havana Transportation Services, and identified the actual component needed for calculating the cost, and finally collected and reviewed the actual, the manual and technical aspect of the component. At the end of the presentation, our achievement, our calculation of the power requirement for the electrical equipment for the solar power bus stops, for example, 60 watts for the lights. Also estimation of the overall cost in installations for the solar power bus. For example, $300 for one bus for providing the lights. And finally, selection of two bus stops from the bus tour in Havana Transportation Services. There are two concerns we would like to address in our project: the creation and adjustment of the governing laws for the implementations, and the time frame for shipment of the materials and the other related expenses. In the couple of next slides, I would like to talk about the PV technology for solar power bus stops. The PV systems usually consist of four major components following the solar panel. The solar panel is made of the modules of solar cells, which can be manufactured with the different type of the materials, such as polycrystalline silicon or monocrystalline silicon. The second item is the battery. The battery can be used to store the energy during the daytime, sunny time, and can be release it during the evening and the night. To prevent the battery from overcharging, charge controllers will be used for PV system technology. The charge controllers adjust the current and voltage from the solar panels for the battery characteristic to meet actually. For some applications, the AC inverter needs to be used to convert the DC powers to the AC power. These two pictures shows the implemented solar power technology in FIU campus, including the four major components of the PV systems. The produced power from the PV system can be used for lights. The number of the lights depend on the size of the solar bus stops. A display. There are a real-time sign which shows the remaining time till the next bus arrives. Delay can be also announced in display. The speakers can be powered by the PV systems. A speaker usually used for people with the visual impairments. The Wi-Fi, we can provide the opportunity to people to have the access, a free Wi-Fi with getting the power from the sun. And also the sensor can detect if there is anyone nearby so that the lights are turned on when someone is waiting the bus, and then we can save a lot of energy. The sockets, in the summer months, it could be possible to use the extra electricity by using the sockets to make it possible to change, for example, the mobile phone, laptops, and other electrical instruments. These two pictures shows the two new solar power bus shelter on well in Corona and San Francisco in California. But however, based on our review, all over the U.S. cities are installing the PV technology for bus stop and actually in the transportation services. As example, Delaware received $1.5 million for solar panel installations, such as Georgia, Illinois, and Washington. Actually, the main motivation for us, that was the main motivation for us to thinking about implementing the solar technology in Cuba. And okay, my teammate Elena continues the presentation.
Well, for this project, we decided to focus in Havana, given its demographics and the annual revenue that it generates through tourism. Havana is the most populated province, with roughly 2.1 million residents, followed by Santiago de Cuba. Annually, Havana receives over 2 million tourists, generating roughly $20 million in revenue. Given its importance as a center for economic development, we also think it is important that Havana sets the standard for public transportation around the country. However, the Ministry of Transportation has been facing many issues throughout decades: instability, insufficiency. The prominent lack of safety and the low quality of services are of major concern. Public buses in Havana operate Sunday to Sunday, 24 hours a day. Over 1 million travelers use the public buses on a daily basis, with waiting times ranging from 30 minutes to an hour and a half. The night service, popularly known as La Confronta, has waiting times of up to 2 hours and even more, as many buses are retired from the streets past midnight. The price per ride is 2 cents for the most commonly used, while the bus tour cost is approximately $4.45. This is equivalent to 125 Cuban pesos, or a week of work for the average Cuban citizen. So it's mostly affordable for tourists. The main routes are now serviced by the Metrobus, as the Camello has been actually retired and sent out to the western provinces, such as Santiago de Cuba and Guantánamo. There are 17 main routes labeled P. They range from 1 to 16, with an extra route named PC. There's 103 other routes and secondary local routes C, in addition to the 3 routes serviced by the bus tour. This amounts to 3,030 bus stops around the city, and only 35% actually have a shelter. The proposed shelters by Sol Urbano seek to enhance visibility, not just for the drivers, but also for the passengers, increase safety, not simply at night, but also in case of a blackout. We also seek to promote renewable energy use throughout the city on a daily basis, and we wish to educate people on the positive impact that this has for society and the environment. We will now show you a very brief clip to help you visualize how Sol Urbano, by combining transportation, telecommunications, and renewable energy, will set Cuba worlds ahead. And now Isaz will continue the presentation.
So in the methodology, first we wanted to estimate the cost. Definitely different quality means different costs. And we got our prices from the online sales like Amazon and contractors estimation. Then we go for bus stop selections. Then we chose a bus tour because it has more accessible information and definitely higher price won't significantly affect the tourist ridership. And you know, there are luxury, however, they don't have any bus stop, they are just a pole. And also we wanted to know that what's the effect of the having a good and new technology and advanced bus stop on the ridership of public transportation. So this is the a proposed bus stop that we are going to speak about. It has 45 watt solar panels, which provides provide 200 lumens per lamp, which able to provide 3 lamps. And we need to have a solar panel support frames and 3 2-watt lamps and 12-volt battery system and a wiring battery enclosure and solar 12-watt charger and controller. All in all, it costs $1,300 US dollars. And then for the route selection, we decided to choose the T1 route, Tour 1, because it has 2 main bus stops which has the intersect with other 2 ones. First one, Plaza de la Revolución, and another one is Parque Central. And this is giving another interface of the city, and that green one is T1, Tour 1. So the main concern about all the decision makers and authorities is to motivate people to use more public transportation and prevent using their private car. So definitely with having a better facility and better quality of the facility of public transportation, people are more motivated to use public transportation. One of the benefits that we can discuss about it is the main benefit actually is having a light. And that's it. So it increased the security of people, especially women, especially children during the whole day. And another one is giving the people more information when the bus is coming, when is the next stop. And also, a good attractive design of shelters will attract more travelers and have a positive impact of the island. Also, it presents the culture of Cuba. And another benefit is having an advertisement. So it can be a very good source of money for the next bus stops. And it definitely can improve the culture of Cuban. Definitely they know that, okay, it can be used by their house and it increases the culture. And so also we have some concern. Definitely the first concern is that vandalism. The vandalism is all over the world. However, we need to know that the solar panels may be damaged or stolen. Also, the seawater has salt. It may brought some problems for the efficiency of the solar panels. And also, the shipment to the Cuba may have been challenging, and convincing the government may be another issue. And then definitely we want to know that, okay, whatever that we said, we want to make it implementable. We need to have planning activities. That planning activities decide that who is going to take care of what, who is the project leader. And the first meeting, we are going to see that we are going to break down the project to different groups. Different people are assigned to different part of the project and establish a location which bus stop are going to be work on and formulate the survey and knowing the people's idea. And then the second meeting, following up it and knowing the people's idea and finalize everything. So as a conclusion, I would like to say that this project is the first project and novel project in bus stop and using the smart public transportation in Havana, which has no one previously worked on the smart public transportation in Havana. And the solar panels and the current situation of Havana and the costs and selected bus stop were explained. Also, we talked about main benefits and planning activities. This is the first study on the smart public transportation in Havana, and any missing potential challenges are definitely undeniable. However, the first is better than the best. Thank you so much for your attention.